Hello and welcome to this video. It's a pleasure for me to see you here again and what we are talking about today. So today we are talking about CVSS, and after I gave you a short overview, we want to discuss a little bit more in detail the dedicated elements of the different metrics. And why? Well, I want to give you all the information that you are able to use the CVSS calculator after this video, and think about what is a critical part of a dedicated vulnerability you see, and how to use the environmental metrics and calculate the environmental metrics so that you can calibrate the CVSS values exactly for your needs. And if you're interested in this, you're right here. By the way, my name is Sven. I'm developer advocate for JFrog, and as you can see, I'm here right now again in the forest, and I will take you to these two journeys, to the forest and to the CVSS metrics. And if you like this video, don't forget to give me a thumbs up, and I really would appreciate to see you as my new subscriber. CVSS, what does it mean, and a short overview. So CVSS is a common vulnerability scoring system, and this common vulnerability scoring system try to make a generic way, or give you a generic way to compare vulnerabilities. This comparison is done by a number, and this number is between 0 and 10. It could be anything with a comma, so not only the full numbers but even with a comma, so 7.3 or whatever. 0 is non-existing, nothing, and 10 is a very, very critical thing, so the maximum critical thing that could happen. The CVSS has different versions, so we have the CVSS version 2, version 3, version 3.1, and maybe soon 4, and it makes sense to check if you have a CVSS number from what version this CVSS number, or what was the version of the CVSS that was used to calculate this number, because they are different. And in every new release of the CVSS scoring system, you have new elements inside the metrics, and it makes sense to see if this is affecting you, yes or no. But we will cover this in a little bit, in a few minutes, a little bit later. And the CVSS value itself is a pure number, means we can use the CVSS number not only for humans to decide which is right order to eliminate the vulnerabilities that are in the system, but as well we can use this for machines, for the computer to decide to activate rules and all this stuff. Okay, so CVSS itself, we have now this generic scoring system. I want to highlight the different parts, the different metrics, and later inside the metrics, what are the elements to calculate this one. I spoke about that the CVSS value is based on metrics, and we have 3 metrics, and the first 2 are often used. The last one, the third one, is mostly not used, but this is a powerful one to make sure that this vulnerability score will fit to your environment. So the first one is a basic metric. The basic metric is a description of the worst that this vulnerability can do. So it's really the highest damage that can be produced. It's the description of the full potential of this vulnerability. And here we have just the description of the vulnerability itself. But in the temporal metric, we are now looking at stuff like, is there a proof of concept to hack this? Is this just a theoretical approach? Is this already used? Is a patch available? And so on. So all the things that are changing over the time. The basic here is, or the thing that you should have in mind is that with basic and the temporal metric, the CVSS score can only increased, never decreased. So it means the base score is a worst thing that could happen, and then if you have already a proof of concept instead of just a theoretical approach, then this score will be increased over the time. So the base score is fixed, will never touched again. The temporal metric will be changed over the time depending on what is in the field, and then there is a third metric, and this is an environmental metric. But mostly nobody is calculating this environmental metric for his own environment, because with the environmental metric we are scaling the CVSS value from the optimal and the biggest thing that could happen down to your environment. I will show you and explain how this is done or how this could happen, but sometimes you have CVSS scores, a very high score, But with your environmental metric, you see that this is not possible in your system. So the CVSS score for your environment is lower than the maximum that is given. And this is more or less a need to calculate with the environmental metric your version of the CVSS, so that you have the right feeling what is a critical vulnerability or not. But who's calculating this base score, and what is the motivation to calculate this base score, for example? Okay, we spoke about these different metrics, and the base score or the base metric is the description of the worst that could happen. And now the question, if who's able to calculate it, is this a central authority? No, it's no central authority. It is more or less done by the person that found this vulnerability, and this could be everybody. And this means you have different targets you want to reach. If you're a security researcher, mostly you want to have a very high base score, because then this vulnerability is good for publications, or it's good to sell, so you will earn more money with this, and so on and so on. So your credibility of being a security researcher is bigger if you found a lot of very high scored vulnerabilities instead of minor scored vulnerabilities. On the other side, if you're talking to or if a company is able to find a vulnerability inside their own product, sometimes this is the worst thing. They're just giving a patch with a comment and some security fixes, and you never know what really happened. And on the other side, if the company is really making this vulnerability public, then mostly they want to have a very low base score, because their product should be safe and they are not doing mistakes and all this stuff. So it's mostly very interesting, or normally, if you really want to understand the score, you need to know who calculated it, why, and so on. But to say the truth, with so many vulnerabilities, we are not able to do this. We have not the time and the money to do this. And on the other side, mostly we are not able to get this information. So what can we do? We can just see what components inside the base score is rated and how much they gave it to every component inside this metric. And then we have to calibrate it. And this is exactly what we're doing with the environmental metrics. But have a critical eye on the base score and how it's calculated, or what are the critical elements inside this base score. After we know what are the base metric, the temporal metric, and the environmental metric is, I want to have a look inside the metric as well. So the basic metric, we have two main groups with this basic metrics, and the first one is an exploitability metric, and the second one is impact metrics. So what does it mean? It means that the exploitability is something like an attack vector or attack complexity. It will have something like, do you need privilege users, do you have user interaction or not. There is a scope. I'm not sure if this is something the same, but it's new with 3.1. It's a more technical thing. And then we have the impact metrics. It's just a confidentiality, it's integrity, and it's the availability. So these are very complex words for me, but I will go one by one through this, so that you will find this matrix inside the CVSS Calculator. I will show in the end in a screencast, so that you can see how you can use it, how you can calculate, or that you can see which metric is affecting in which, or how heavy a metric is affecting the CVSS score. I want to explain a little bit the different elements inside this metric, and the main thing here is from this attack vector. What I'm describing now is that we have this different values you can use. So if you're looking at this vulnerability calculator, CVSS Calculator, I will show it in the end, then you will see that you can select for the attack vector different values. One value is the network. Is it possible to use this vulnerability of the World Wide Web, so over the network itself? Then this is very critical, because everybody can start it. Is this just possible about some communication interface like a Bluetooth device or network device? Then it's you need some kind of localization to use this vulnerability for your own, whatever you want to do. And then the next thing is, do you need local access to this one? This could be you have access to the keyboard, you have access to a printer or whatever, or do you have the possibility to, or you need to log in with a secure socket shell, SSH, to have a terminal on this system. So do you need this one? And the last one is you need to physically manipulate the system. So, and as you can see here, so if you can attack over the network, then it's the highest risk because everybody can do it. Even you should select network even if it is just possible inside the local network. So network is really from somewhere in the internet or somewhere from the network you can attack. On the other side, the other extreme is physical. So, if you need physical access, so really you have to open the system, manipulate it, this is something that is way more difficult to use, and this is a lower risk if you're comparing all of this. So if you want to validate or if you want to calculate the attack vector, then you have to choose between network, adjacent, local and physical. And well, this is you have one thing, you have behind this different multiplicators. So if you are calculating the value, you have for every thing you could select a dedicated multiplicator. I'm not talking about the multiplicator itself because from version to version they are different, and if you're calculating the CVSS value, you should use the CVSS Calculator from NIST. This is the organization that owns the CVSS, and this is providing this calculator, and there you can use the logical steps: network, adjacent, local and physical. And this is what you should use to calculate or to verify what is most effective, or what is increasing or decreasing the value if you want to learn it. So the next thing is attack complexity, and the attack complexity has just two values, low and high, and it means the following. So the complexity is low if you have always the same things or steps to do, and it doesn't matter if it is installed here or there or somewhere, you have always the same steps to do, step A, B and C. No extra knowledge, no extra things to do, just this one, like a cookbook. And if this is the case, then it's very reproducible, and you have always, with this reproducibility, you're always able to use this vulnerability. And this means this is a high risk because you don't need special knowledge. On the other side, if the complexity is high, means you have first to get some information about the installation, some special configuration must be there, you have to do some individual steps because for this environment you have some different things to do. Then the attack complexity is complex, and it means it's not so easy to attack the system, so the value will be lower. So low complexity means a high risk, high complexity means a lower risk. So next one is the component personal rights, and here we have three levels. If you can attack the system just with anonymous user, so without any authorization or authorization, then you can just use low, or this no user rights are needed. If you need at least a logged in user or some user but not a privileged user, you are in the middle of this scope. And if you need administrative rights like root permissions or something like this, then it's with high permissions. And the value here is it is more critical if an anonymous user can do this attack, and it's the lowest risk if you need root administrative rights to use this vulnerability. So without any user rights or personal rights, the vulnerability is more critical than compared to you need some rights or you need explicit root rights. The next element is a user interaction. Do you need a user interaction? Yes or no? And these are the only possibilities you can choose. And what is a user interaction? So for example, if you can use this vulnerability only if exactly at the same time a user is installing something, printing something, doing something, clicking something, then it's a higher complexity. So you need exactly a user that is doing something exactly at the same time you can attack the system. And if you don't need it, then you can just do it at whatever time you need. And this means the higher risk is if you don't need user interaction, and the lower risk is you need a user interaction. And this is exactly what you can select. Yes, you need user interaction, or no, you don't. The next element I want to discuss is a scope. Scope is new since CVSS 3.1, and it's focusing or targeting on environments like Docker, so virtualization, operating systems, or whatever in sandbox. So it means if you have, for example, a Docker environment, and inside your Docker instance you have root rights or administrative rights, and you can destroy something, that's one thing. But if you're able to break out of this instance to the underlying operating system with root rights, then this is way more critical. So you have two choices to select. It's changed and unchanged. Unchanged means you have no scope change, you are still in your sandbox, you can't escape. And changed is you are able to escape out of the sandbox, and you can attack the underlying operating system or infrastructure part. So low risk is unchanged, high risk is changed. Now we are reaching the point that we are talking about the impact metrics, and the first one is confidentiality. And here we have 3 levels. For example, if you are able to steal the root password, you can modify the whole system, and you can delete or compromise the whole system, you have access to all data, then you have the complete loss of confidentiality here. If it is just a user, and in this area there are manipulations or data loss or whatever, then you're talking about a partially loss of the confidentiality. And if it is just a few data sets, or you don't care about this because it's just a low priority system and the data, they are not important, then you can say you have no loss in confidentiality. So it means you have to decide how big is the impact here at this point, and mostly you can measure it or have an advice what you should select. If you have a very important or a user with very high rights, mostly the whole system is not secure anymore. If you have just a regular user and you have a dedicated scope, you know where you lost the confidentiality, then this is this area. Or if it is just random and you don't care about it, then you can say low. So if you have the highest one, the first one, that's the highest risk, and the last one is the lowest risk. The next impact score I want to address is integrity of the system. So if, for example, someone with root or administrative rights was, if this password is compromised and you have a user that is manipulating the system here, and you don't know if data is compromised, if data is changed, deleted, randomly edited or whatever, and you don't have an area, so it could be everywhere, then you have the complete loss of security here at this point, the complete loss of integrity. And if it is just a project, if it is just a department of a company or whatever, so if you have it just in a partial area, then it's a partial loss of integrity. Or you have just these 5 data sets, you can revert it, or you know, or you can make sure that there is no manipulation, there is no data loss, there is no edited data and all this stuff, then you have no loss of integrity. So you have to choose between the 3. The worst case, if random, you have no clue what happened, you have no clue if it is added, removed, modified, whatever, or you have it just in a partial area, or you have dedicated values you can revert, or you have definitely no change in the system. The next impact score is availability, and here we have 3 possibilities. The availability is completely destroyed. So you can't use this system anymore. It's encrypted, it's just deleted, it's whatever. So then you have no system anymore that you can use. So the availability is 0. There's a the bad thing that could happen, the worst case. The next thing is the system can be used because it's just partially down, or it's just slower or something like this. Then you have partially availability. Or if it is just working as normal, there's happening something, but it's completely available, then you have none. And here you have exactly the three values, high, middle and low. And yeah, that's the impact score availability. The next thing I want to highlight are the temporal metric. The temporal metric is defining everything that is changing over time. So the base metric is just a definition, what is the biggest damage here in the system, so what's the worst case scenario. But with the temporal metric, we are looking at this point if we have exploits and what this quality of this exploit is. And we have different states we are defining here. So the first one is it's just not defined. Not defined means we have no idea if there's an exploit available. Is this implemented as a virus, worm or something like this, or is it a conceptual thing? It's just not defined. So we know nothing, and this is the worst thing, or we think this is in a way that we have to calculate it as a worst case because we have no information. Then the security level high or the risk level high means that this code of this exploit is production ready. Production ready means it's available as a full autonomous virus, worm or some piece of code that is working more or less completely independent. So it's infecting different systems, jumping from system to system. You need no manual interaction really with this, so really autonomous working code, so that everybody without technology or technical knowledge can use this to damage a system or use this vulnerability. The other thing is, if you are thinking about we have a functional piece of code. The next level, lower level, is a functional level. The functional level means you have some piece of code, you have some instructions, all this stuff, but it's not production ready. It's more like you have here this is toolings, you have to change it a little bit, you have to tweak it a little bit from time to time, you have to see how you can adapt this technique now to the system you want to attack. And this is a functional piece of code, and for this you need a little bit more technical knowledge. It's not really usable from others, and it is not done autonomically, so autonomously and automatic. And the next lower level is just a proof of concept. A proof of concept means that you have in some kind of controlled environment tested if this vulnerability is really available, technically usable, and then you have some in a very clean environment this proof of concept running, but you can't really use it in the wild, you can't really use it in real life situations, so you need to adopt a lot of stuff. It's far away from being a product. And the lower thing is if it is just a concept. So if it is just a theoretical thing, so it's called here unproven. So you have a theoretical thing, so this could happen, but there is no technical validation of this vulnerability so that it's really working. And that is the lowest level. So we have these different levels from not defined as the highest risk to high. High is something that's running completely automatically and everybody can use this to infect other systems, or it's completely automatically done like a virus from system to systems jumping. The next one is a functional piece of code that's available. So you have some piece of code and you need a lot of knowledge to adapt it to the system. And the next lower one is a proof of concept. It's just done by a research team, so yes, it is possible to do. And the lower thing is it's just a theoretical vulnerability. Okay, now we are talking about the availability of a patch. So we have different values here now we can select, and the most critical one is if it is undefined. Undefined means we have no dedicated knowledge about if there is a patch, yes, no, and what's the current status of this patch. The next one that is critical as well, is more or less the same risk, is the definition there is no patch. So definitely it is not patch, or it is not possible to patch. So it's a little bit less strong than undefined, because we know it is not able to be fixed, but it's still a very critical one. The next one that is coming is the workaround. A workaround means it's mostly from other users or third parties or whoever is giving this workaround. It could be even the project owner or the product owner. And it's more or less, we have the possibility to configure something, to delete something, to override something, whatever. It's a it's a workaround. It's not a solution. It's just to minimize the risk or to make it less available, but it's not patched. The next level is it is a temporal fix, so it's a temporal hotfix. So the company or the project owner will give you some code changes or product changes, but it's not the final version. It's really just a minor version, and it's minimizing the risk or just simply closing the backdoor that you have there, but it's not the final solution. And the lowest level of risk is there is an official patch, and the final patch that's definitely eliminating this vulnerability. So the next thing I want to have is the report confidence. It means, is it really true that this vulnerability there? How many people are validating this information, and what is the quality of this validation of this vulnerability? And here we have exactly the same like the others. So if we don't have information, if we don't have any confidence that this is really existing, then this is the worst case, because we just don't know it. The next one that is critical is, yes, it is confirmed. So we have access to the source code, to the components. You can compromise the system based on this vulnerability information. You can verify that this vulnerability is existing. And this is a state of being confirmed. The next one is that you have this level of reasonable. So it could be that it's there and you have different informations about it, or partially the possibility to reproduce this vulnerability or to scan some parts of the source code of this different parts of hardware. It could be hardware as well, but here we are talking about software. So if this partially you have the source code or from the environment more information, so that's reasonable that this vulnerability is there. It's not confirmed, but different authorities say, yeah, it's reasonable that it is possible to have this one. And the other thing is it's just unknown. So it's unknown what's happening. So it's closed source, it's a weak description. You have no valid points to prove this theoretical approach and all this stuff. Then it's just unknown. So you have definitely no information about this stuff. And this is more or less the evolution of maybe there is something, we don't know it, then we have it as a reasonable thing, and then yes, it's confirmed. So this is more or less the evolution of the report confidence element. So we saw now the basic metrics, the temporal metrics, and this is mostly coming from outside. So this is a core CVSS core that you will be able to see in programs and vulnerability database and all this stuff. But now we want to go to the environmental metrics. Environmental metrics are used to scale this CVSS core based on your needs and your infrastructure to a real for you effective CVSS value. And this could be a little bit higher or lower CVSS core. And I want to show this CVSS calculator so that you can see how it works and how it's influencing the CVSS core. But the main thing is that the basic metrics or the elements of this environmental metrics is more or less a modified version of the previous values that I described. So to show you how it works and how you can use this calculator, I will go home and will show it at the computer. So we will have a short screencast with what are the environmental metric elements and how it's used, and how you can see how this is reflected inside the modified CVSS value. And this is very important for you, because this is a true for you usable CVSS value that is mapped to your environment, and based on this one you should make your decisions, and not only about this plain CVSS core that is published by the database or by the tool that you're using. So see you in a few minutes at the screencast. Okay, now we're coming to the vulnerability scoring calculator and how to find it. So what you will find here on first.org, here in first.org, you will find all information about the organization in itself. And here we have under standards and publications and standards, the common vulnerability scoring system. If you're going here, you will see here the different versions of it. I'm not going with the mouse over because then the menu is just jumping. So you have the version 1, 2, 3, 3.1, and if you're going to the latest, here in this case it's version 3.1, I see not only the specification and user guide, I see the calculator itself. The calculator itself is first quite plain, and this means that you have to put the CVSS values, for example from X-ray, here in. So we see, for example, we have an attack vector, you can do it over the network, we have an attack complexity that's low, we need, I don't know, some low privilege, but we have no user interaction necessary, the scope is maybe unchanged, and I don't know, low, so something like this. So now we have here the scope 6.3, and the temporal score, we find the values. So for example, if it is a proof of concept, a functional code example, or it's even a full autonomous code, we have the remediation level, if you have a temporal fix, for example, or it's unavailable, or we have a workaround, something like this, and report confidence, it's reasonable that this is existing, or it's even confirmed or unknown. So you see that these values are changing, and to analyze the CVSS score, what you have here and what are the critical things, for example, is scope something that is very critical, yes or no? And you see, oh yes, if I can escape the scope, scope is something new here in the CVSS version 3.1, then you can break out of the virtual system into the whole system, and this is something that is very critical, for example. Okay. Then, if we're going here down, we see the environmental score. And the environmental score is more or less the possibility to adjust all these metrics. And as you can see here, the latest one, the 6.9, is here reflected. And now we start working on it. For example, we say we have an integrity that requirement that is very high, then it will change immediately the CVSS score to a very high number. If it is just medium, if it is low, or it's not defined, if you don't want to touch this value. Okay, let's say we have a medium requirement, and the availability for us is very high in this system, because if this system is not working, we can't earn money, or processes still not, or it's not functional, or whatever, then you can adjust here the availability requirement. So if you have this one, okay, this mostly is at least low, medium, or high. It really depends. Let's say it's medium. So the next is that we are modifying. For example, here the attack vector is over the network, but it could be that in our environment I have at least the need to go over an adjusted network. And this is reducing immediately the vulnerability from not defined or over the internet up to or down to a dedicated network segment that is isolated, for example. Then this is not so critical anymore. Modified attack complexity could be high because I have some environments, firewalls, whatever. I need maybe at least low requirements on the privileges. I have user interaction. I think here we have no user interaction, but maybe we have some predefined things, or we have a modified version, or we have something in front of, so we need at least user interaction. Then you see that it is changing slowly, and so on and so on. So here it was scope was changed, but in our case there is no scope, so it is unchanged. So it's reducing it because we don't have it. We had just installed without any virtualization. There is no way to escape. Then this is definitely changing the environment, and so on and so on. So if you have done this one, then you see that from a original 7.4 it could go down to a 4.4 for my environment, but it can go exactly in the way in the other way. So for example, you have here the scope unchanged and no user interaction, and you say, okay, in my one the scope can be changed because now we have it, and I need, I don't know, user interaction is none, and so on and so on. So what I want to show here is, first of all, we have the CVSS calculator. Make sure that you're always using the CVS calculator that fits to your specification. So if you have 3.1 CVSS values, use the corresponding calculator. You can analyze here with the base score and the temporal score what is the difference between a temporal fix and a workaround, for example, or an official fix, or if it is unavailable. So you can analyze the importance of every element inside the scores. And the most interesting thing is you can calibrate the CVSS value for your own needs if you have the possibility to work with environmental scores, and then you can modify and see if this CVSS value is so critical for you or even more critical. So altogether, will give you a very good way to understand the dedicated elements of the CVSS value. You can understand how it's built with base and temporal score, and you can modify with environmental score so that you can see how important it will be for you. So everything together is a nice way to learn more, practically learn more about the CVSS system itself. And have in mind, you have here the specification and user guide, and so you can see how this is used, defined, and so on and so on. So this is the CVSS calculator and environmental score. So this was a lot of stuff. We checked the base metrics, the temporal metrics, and we had a detailed view on the environmental metrics. And this is what I really suggest to you, is that you should have a look at this environmental metric so that you can scale up and down the CVSS score based on your needs, and that it fits best to your infrastructure that is affected by this vulnerability. So in this video I use the CVSS specification version 3.1 and have a look if you are getting some CVSS value, so that you're aware of if it is a version 2, 3, 3.1, or maybe soon in the future the version 4, so that you're aware of the different values inside the metrics, so that you can calibrate the environmental metric based on exactly this version and specification you have. So far, that's all I wanted to say. If you like this video, give me a thumbs up, please, and it would be a pleasure to see you as my new subscriber. So please subscribe my channel so that you get informed every time I'm publishing a new video. By the way, if you have any comments or suggestions, write it down in the comments so that we can have a discussion about it, and I can start planning my next video about CVSS if you have any ideas about what is necessary or needed on your side. So just let me know. On the other side, my day is done. I will go now a little bit around the forest. I will enjoy the rest of the day, and then I will just go home and checking if this recording is perfect. And on the other side, whatever day and time you're watching this video, have a good rest of your day. Stay safe and see you.